So I want to look at a pattern here of these first four problems that we've done. You notice that the absolute value of the first integer is always 5, and the absolute value of the second integer is always 2. I'm changing around signs. Sometimes it's positive, sometimes it's negative. What you should notice is if I was to create a new expression using addition, we can actually get these same solutions every time. Let me show you what I mean. So I intentionally highlighted the minus sign in each of these problems just so you can understand the minus sign in place of the negative sign, where this is a minus sign and this is really defining this is the opposite of positive 2, negative 2. So I'm changing this minus sign to a plus. And what I'm going to do to this number is change it to a negative. So 5 plus negative 2. This goes back to something that we said on a video that you got earlier in the week, and it's about absolute value. So the distance of number is from 0. And we said if you have integers in absolute value, you're going to take the sign of the number with a greater absolute value. So in this instance, negative 7 had more absolute value than 5. It was further from 0. So the sign at the end would be negative. So getting back to trying to recognize a pattern here. The bigger sign out of these two numbers, since their signs are different, is the positive number, since 5 is further from 0. So this would be positive 3. If I did that same situation of changing the minus sign to a plus sign and turning this into the opposite, watch what happens here. It's 5. We change that green minus sign to a green plus sign and change negative 2 to its opposite, positive 2. I still end up with 7. If I do that here, I still start with negative 5. I'm going to change that minus sign to a plus. And whatever number we're taking away, in this case 2, we change to the opposite. So it's going to become negative 2. Now in this instance, the two signs are the same. So just like 5 plus 2 is positive 7, negative 5 plus negative 2 is negative 7. We're going to keep negative 5 the same, change the minus sign to a plus sign, and then make negative 2 the opposite. In everything we do in math, just like we do in the real world, we try to shorten things and explain them in really concise terms. What we say in our class is these 3 words: add the opposite. And this is only true of subtraction. So if you remember, when we make a bed, I used the analogy the other day that said, even if it's cold out, you put your sheets on. You're going to put blankets on after. If it's warm out, you put your sheets on. So with integer operations, with addition and subtraction, we're always going to do addition. Math teachers, in their head, I know I've talked to Mr. Fitzgibbon, Mrs. Tenalia, other math teachers about this. I do this quickly in my head by just saying, oh, this is negative 5 plus negative 2. I do it like a snap in my head. Let's try that out. I'm going to skip using these counters and just try to add the opposite. So I'm going to keep 10 the same. We're going to make that a plus sign, and then the negative 2 becomes a positive 2. It equals 12. Just to prove it, here I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it asks me to take negative 2. I don't have any negatives here, so we've got to bring some over. But I can't just invent negative 2 out of nowhere because I started with 10. So to keep it at 10, really what I did was add 0. So now I started with 10 still. You notice that there's 4 integer tiles over here, but the total value of them is 0. Now I can take negative 2, and if I take those negative 2, the 10 I add 2 more, it becomes 12. So what I just did, it looks like it's valid. Negative 9 minus 2, I've got a 9, I've got a 2. It should equal negative 7. Ow! So here's the other issue. We always say in 8th grade math, kids have such a false sense of confidence because of these furry numbers. I said at the beginning of the video. And right there, I fell into a trap. Every single time when we do these problems, we're going to ask you to rewrite the problem so that you are adding the opposite. Now you can see, okay, negative 9 plus negative 2, it can't equal negative 7. it's going to equal negative 11. That is the correct answer. Negative 7 is the bad answer. I like to call those wolves, the answers that seem like they would make sense, but they're out to bite you. 8 minus 5. This is one of those, I think it is the exception to the rule. It's just going to equal 3. It's second grade math. Bigger number minus a smaller number, they're both positive. First grade math even. Negative 8 minus 5 is different, so I'm going to rewrite that. Negative 8 plus negative 5. I've got two negatives and I'm adding together, so that'll equal negative 13. Negative 8 plus 5. So we're going to change this to subtraction. Ow! All right, so this is another one that can burn you. Remember, this is why I use the analogy. Sometimes when we use analogies that have nothing to do with math, it helps you remember math. We said that you put sheets on a bed and think of sheets as being addition. So you're always going to do addition, but sometimes you don't need to use another option. So in the summertime, you might just need sheets on the bed. And this is a case like that. You have a plus sign already. You've got the problem exactly where you want it. You don't need subtraction to solve it. You need addition to solve subtraction, but you don't need subtraction to solve addition, if that makes sense. Just do this thing out as it is. We go with that rule of absolute value. So if you have more negatives, it's going to be negative. If you have more positives, it's going to be positive. Because you can see that the signs are different in this one. This is a negative, this is a positive. So the absolute value of negative 8 is bigger than the absolute value of 5. So we know the sign's going to be negative. It looks like there are a difference of 3 between them. So your answer here would be negative 3.